Hello guys, so tomorrow we've got a quiz. This is the homework I gave out. Said I would work it over, so take a look, make sure you have the same answers as I do, or pay a lot of attention and see why I did what I did. First section is adding decimals, and for adding and subtracting, the most important step is to stack them neatly by place value. And we know people say do it by decimals because they're always after the ones. So whether you say stack it by decimal or stack it by place value, you're really saying the same thing. So I'll just rewrite my 9 and 97 hundredths over here, okay, and make sure I don't make the mistake doing that. And then I'll say, all right, 5 plus 7 is 12. I put my 2 here and carry my 1. 9 plus 0 is 9, and 1 more is 10. 0 here, 1 up here. My decimal. That's it. You basically ignore it. 1 and 9 is 10. 2 more is 12. So 2 and 1. 4 and 1 is 5. Should have had 52 and 2 hundredths. Next, 3.8. I'm going to go a little bit faster, otherwise this will be a 30-minute video. So next, 3.8, stack it by my decimal, 3.8. Okay, I fill in invisible zeros so that I don't make mistakes with placeholders. 5 and 0, 5, 0, 0, 0, 0, 8, 8, decimal, 9, 3, 12, and then I have 2. So I have 22 and 805 thousandths. 899, 4.06, this is a neat one. So 899, I know there's an invisible decimal there, so I'm going to line it up by that decimal, and then I'm going to work over this way, okay? And then I'm going to fill in invisible zeros, all right? And I have 0 and 6. Oh, let me do these zeros too, okay? And it's all plus. So 0 and 6, 6, 0, 0, 0, decimal. 4 and 9, 13. Then I have 10, and then I have 9. So I get 903.06, final answer. Over here, stack it by that decimal again, so 13.628, and then put a 0 there. I've got 8, I've got 10, I've got 11 and 12, decimal, 12, 13, and then I've got 9. Okay, 93 and 208 thousandths. All right, subtracting, same thing. You just run into struggles when you go through 0. Everybody does. So you just have to be slow and remember, like I do, borrow slowly. Don't borrow like too fast or you'll make simple mistakes. So I'm going to rewrite this over here by the decimal, stacking by the decimal. Okay, and I've got 16.8. I'm going to line that up and sure, go ahead. Thank you.
Can I?
Yes, please. Okay, no problem. Then I'm going to look at this and I'll say, all right, 3 minus 8. Can't do it. Number one mistake is people will look at this and say 5. So 3 minus 8, you can't do it. So you borrow, and we'll call that a 1, and now this is going to become a 13. I took a 1 and made it 10 tenths. So 13 minus 8 is 5. Decimal. 1 minus 6, can't do it. So 3 and 11. 11 minus 6 is 5. 3 minus 1 is 2. 25 and a half is your answer. Next, subtract 4.2. So decimal lineup, very neatly. Add in your zeros and then subtract. Okay, 3 minus 0, 3. 0 minus 2, can't do it. So you become 0, you become 10. 10 minus 2, 8. Decimal. Okay, borrow u, turn u into a 10. 10 minus 4, 6. 7 minus 0, 7. So we should have 76 and 83 hundredths. 15 and 2 thousandths. All right, here we go. I'll write this one underneath. So minus 9, decimal, 359. Okay. I don't really need the 0 there. It's kind of an easy one, actually. 2, no. So I come over here and I borrow. Actually, this is kind of complicated. So 4, and this turns into 10. Scratch you out. 9, now you become 10. Scratch you out. 9, now you become 12. Now I can proceed. 12 minus 9, 3. 9 minus 5, 4. 9 minus 3, 6. Decimal. And I can really just say this is 14 minus 9, and that's 5. Because notice, if I didn't do that, I'd say, oh, borrow from you, turn you into a 14. You know, that, it didn't do anything. 5 and 643 thousandths. Final one on this side is 100 minus 37.25. That's interesting. Okay, 100.00. That's going to be a lot of zeros. Going to be kind of weird. So 0 minus 5 is where I begin, and I can't do it. So I got to come all the way here. I can't borrow till here. So I go like this very slowly. 0, 10, 9, 10, 9, 10, 9, 10. The reason I don't go too fast, I don't trust my 9 shortcut. I feel like I would accidentally make a 9 there. And then the whole thing is wrong. 10 minus 5, 5. 9 minus 2, 7. Decimal, decimal, decimal. 9 minus 7, 2. 9 minus 3, 6. And we're finished. And really, guys, I didn't do this on any of the other ones here, but you want to be sure you get this right. Then add these two numbers and make sure it equals 100. So I'll just come right down here and do that. Plus 37.25. Okay, 5 and 5, 0, or 10, you know. Carry this over. 9 and 1 more is another 10. Okay. 2 and 7 is 9 and another 10. 9 and another one is 10. Sure enough. Okay? So make sure if you do double check, say this was my answer right there. Okay? Backside, a little bit more complicated, but I'll explain the first one here just a little bit more than the others because time is of the essence. So I want to kind of stack these, but I don't care where the decimal goes because I'm going to move it out and rewrite it anyways. Okay? I don't line these up by the decimals because it'll trash it. I'm going to push them all the way to the right like the bookshelf. If I can jump over here for a second, you recall us talking about that in class where I'd say, just shove it right for now. You push it all the way to the right. Doesn't matter what the place value is. You're going to move them out, and then these will look like ones, won't they? So right now, I like to move the decimals out, turn them into whole numbers, multiply, and then move the decimal back in. That's my strategy. That's what we've been talking about. If you have another one that works for you, consistently do it, but you need to have the right answers. So this we moved out once in the top, once in the bottom. That's a total of 2 places. Remember that for later. So 33 times 44. I'll put this here, and I'm going to ignore my decimal. Okay, so 3 times 4 is 12. 3 times 4 is 12, plus 1 is 13. Okay, I'm going to shortcut this. I know that 3 is going to get me the same stuff. I just put a 0 here, and then I'll write 132 again. Okay, you've already found those multiples. So 2 and 0 is 2, 3 and 2 is 5, 3 and 1 is 4, and then I have 1. I have 14, 5, 2. I want to move the decimal back in 2 places from the right. And I'm ending at 14 and 52 hundredths. Okay, that's my final answer. And I keep forgetting to do this, guys, but if you want to be right, like if I was graded on this, I'd be doing this. Estimate. This is close to 3, this is close to 4, okay? That would be 12, and you know it's going to be a little bit more because this is a little bit more than 3, a little bit more than 4. So your answer, estimating, should be close to 12. If I had a decimal here, that's way far away from 12. Over here, it's even further. It's the biggest clue that your decimal's in the right place, is that estimation in the beginning, to round it and then multiply. So over here, I'm going to say, all right, move you twice out, move you once out. That's a total of 3 times out. And then I now have 752 times 9. Oh, this is in a way easier than this one. 9 times 2 is 18. 9 times 5 is 45, plus 1 more is 46. 9 times 7 is 63. 4 more is 67. Now I move that decimal back in 3 places. 1, 2, 3. Whoa, 6 and 768 thousandths. And I'm not going to round it because nobody's given me guidance to, and I didn't go forever. I'm only at the thousandths place. But look at this for a second. Round this to the nearest whole number. It'd be 8. But then notice 0.9. We talked about this in class, how when you multiply by something less than 1, your number is actually going to shrink. So it does make sense then for it to be here. It would make way less sense for the decimal to be anywhere else. So the decimal is just to make sure you have the correct sort of place value for your answer. If you mess up the calculations, it's kind of on you. It wouldn't have mattered where the decimal was. 500 times 2.4. I'm going to take a shortcut, huge shortcut here, and go common sense on this one. Okay, 500, I'm going to hide these zeros, and I'm going to say 2.4 times 5. All right, I already know that's going to be close to 10 something, right? 2 times 5 is 10. 2.5, it's probably closer to 12. And now I'm going to hide this decimal, okay? I better be careful with this. I'm getting a little crazy. So I moved it out once, so 4 times 5 is 20. 0 and a 2. 5 times 2 is 10. 2 more is 12. So I have this, 120. Now I'm going to add 2 zeros that I lost, but I'm going to move my decimal back in from this whole thing. I don't know if that makes sense. I like to combine different ideas so that I can just keep myself on my toes. So I'm getting 1,200, okay? And then I do my sanity check here, and I say, well, what's 500 times 2? That's 1,000. And then a little bit more, 1,200 actually makes a lot of sense. So that process just worked. Last one, stack it and go. 43.4 times 5.6. I got 24. Oh, move the decimal out first, guy. Okay. So I moved out a total of 2 times. 6 times 4 is 24. 6 times 3, 18. 2 more is 20. 6 times 4 is 24. 2 more is 26. Now it's this 5, but it's really 50, so I put a 0. 5 times 4 is 20. 0 and 2. I'll keep this 2. 5 times 3 is 15. 2 more is 17. Cross that out, put a 1. 5 times 4 is 20. 1 more is 21. Add those up. 4, 0, 13, 4, 2. Move the decimal back in twice. 243 and 4 hundredths. That makes sense. 40 times 5 is about 200. A little bit more, rounded up to 6 is 240 actually. Okay, dividing. Biggest thing here is you need to rewrite all of these ones into sort of this division bar form, the bank vault. We want to remember the vault is kind of like a mirror, so if I move the decimal on the outside, I need to match that many moves on the inside. But I also need to be comfortable where if I end up like this, I don't need to move this decimal anywhere. I can just say, if my outside number is nice, I'll just move this decimal up, and then I'm finished thinking about it. It's called set it and forget it, and that happens a lot here. So I might just go through now and adjust all these problems before I start. So I have a 3 on the outside, means I don't need to move the decimals. 3 is a really easy number to work with, so float that decimal up. 5 is on the outside. Another easy number to work with, so float that decimal up, and then don't think about it anymore. However, 0.4 is not an easy number to work with, so I'm going to move this over to make it 4. If I move the outside once, I need to move the inside once and only once. And people say the decimal will disappear when I rewrite it as 56 divided by 4, but it didn't. There's an invisible one here, and there's an invisible one there. If I need it, I'll use it. And one of these problems we will. I'm going to rewrite this, and I'm just going to, oh, this is a neat trick, 42.3. Okay, I don't like 0.5. In a way, I actually do. I could just double 42.3, but we're not really there yet overall. So I move this, and then I move that. So I'm going to have 5 on the outside, my divisor, 423 on the inside. Over here, I've got, this is starting to get messier and messier. All right, I don't want to have a 0.12, so I'm going to move this twice to make it 12. 12 on the outside, and then I'm going to move this just twice. It has to match. It's a mirror. So I need to write that exactly that way, no different, 40.8. Now I'm going to float this decimal up and put 1 right here. And rewinding a bit, there was an invisible decimal here that's not going to move, so I could even float it up here. I could put a little dotted line there and say if I need it, that's where I know my decimal goes. Okay, because I'll be doing 0.00 if I need it. Proceeding, 25 on the outside. This is going to be interesting. And 5.68. Well, my outside number is 25. I can't get any easier. So even though my inside one is terrible, I'm going to keep it right there. And you'll see why later. 5. This is 25. I don't like this is the outside, so I need to move this twice. So I'll move this twice. There was an invisible 0, invisible decimal, so now this is 5 on the outside, 2,500 on the inside, and I will not move the decimal back at the end. Last one, ugh, but best practice probably. Move you twice, move you twice. I am getting to 4 on the outside, and 82 on the inside. All right, back through these so we can go kind of quick. 3 goes into 4 one time because 3 times 1 is 3. Notice I don't write this number, I just rewrite the number that I have above, otherwise I'll have tons of mistakes. This has to be a multiple of 3. Minus that I have 1. I bring down a 12, 3 into 12 4 times because 3 times 4 is 12 on the nose. So I'm 0, but I still need to use my last digit here that I see that's not a 0. And that's not, that's complicated. You have to do all the zeros before the decimal place, but not the ones after if you have extended zeros because it go on for infinity. Sorry, got distracted. All right, 3 into 3 one time, and then subtract that, and that's finished, zeroed out. So 1.41 is my answer. And a great idea, I don't have time to do this with all these, is to go back through and say, all right, I want to make sure I'm right. So is 1.41 times 3 actually 4.23? You move your decimal out twice, and you ignore it, and you get 3, 12, 4. And then you move it back in, sure enough, yes. So that means our 141 was correct. 5 goes into 2 0 times. Write your zeros. 5 goes into 27 then, 5 times. Subtract 25. I have 2 left over. I bring this 2 down. This is interesting. 5 goes into 22 4 times, but that's not perfect. I lose 20 now, and I have 2 left over. I can't stop. This isn't our old ways where we did remainders. This is decimals. So I'm going to add my invisible 0, my ghost 0, bring it down. 5 goes into 20 perfectly 4 times, and you're finished, 5.44. Okay, because you'd have to subtract it because you know, perfect. Okay, next, 456. 4 goes into 5 once. You subtract that, you have 1. Now you bring this 16. 4 goes into 16 4 times. So it's actually 14 perfectly on the nose because your decimal will end right there, but you don't need to show it. 0. Next, going fast because this video is getting long. 5 into 423. 5 goes into 4 no times. 5 into 42 8 times, minus 40. Okay, and if you need to, you can pause and kind of go slower to say, like, how do you get that? I have 2 left over. I have 23. 5 into 23 4 times because 5 times 4 is 20. Again, I'm not done, so I need to try this and put a 0.0. So I put a point here. 30. Now I'll be finished. 5 goes into 36 times because 5 times 6 is 30, and I'm zeroed out. Over here, 12 goes into 40 3 times. Okay, put your 0 there. Sorry, 3 times 36. Minus that, I have a 4. Decimal's already there. I bring you down 48. Oh, this is a nice, easy one. 12 into 48, 4 times perfectly because that'll give you 48, and I'm zeroed out. 3.4. Next, 25 into 5.68. So no decimal, and then 25 into 56 is 2, right? Because 25 times 2 is 50. I have a 6. I bring the 8 down. 25 fits into 68 twice again because subtract 50. I'll have 18. This one might go on for a bit. So I'm going to add an invisible 0, and I'm going to bring it down, and I'm at 180. So 25 goes into 187 times. Sorry, I just know that because 25 times 7 is 175. And so you might do this and then say, all right, I'll stop. I mean, the good news is it's a 25, so it's going to stop actually relatively soon. It's not going to go on forever. You just need to add a few zeros. And this one's actually the 10,000th place, but 25 into 50 twice because 25 times 2 was 50, and you're zeroed out. If you had to round it to the nearest hundredth, you would tell me it's 0.23. If you had to round to the nearest thousandth, you would tell me it's 0.227. Obviously using better terminology than me. This was a good move, so this will be easy. 5 into 2, no. 5 into 25, yes. 5 times minus 25, 0. Now, you still have to do this. Know that you have the decimal here, and you have to work all the way to that. So still bring down 5 into 0, 0 times, because 5 times 0 is 0. Do this just so you don't make a mistake. When you're better at this and have done it more, you can just put the zeros in. But bring this down, 5 into 0, 0 times, because 5 times 0 is 0, 0 is 0. Okay, that's our answer there, 500. 500 nickels would have made $25. That's the way to think about these. I think about money all the time with, especially when I see 0.05, that's like a nickel, 5 cents. Final one, 4 into 8, 2 times, because 4 times 2 is 8. Subtract, I've got a 0, bring this down, 2. 4 cannot go into 2, so I have a 0, But I'm going to minus 0, and I'll be here at this 2. So I need to go decimal, ghost 0. So move that decimal there. Don't forget about the decimal above and below. You can see all my paper. I think I remembered, hopefully. Bring this down, 20. Go slower than I am, and it'll be fine. 4 goes into 20 perfectly 5 times, because 4 times 5 is 20. Subtract it, and I have 0. So my answer there is 20 and a half, which is great. Okay, guys, if there are questions and you still don't understand why I did a certain step in this, email me. I'll do my best to get back to you tonight. Hopefully the video helps some people get ready for our quiz tomorrow. Everybody can do well. See you then.